Okay, let's dive right into this. Welcome back to another explainer, everyone. Today, we're tackling something that I literally see trip up countless students every single year. We are looking directly at the Cambridge Computer Science and Information Technology exams. Specifically, we're focusing on syllabus codes 0417, 0478, 2210, 9618, and of course, 9626. And we're going to look at these exams through a very specific and maybe slightly unexpected lens today, the marathon. Because taking these exams, especially when you hit those incredibly complex, high-mark questions on things like wireless sensor and actuator networks or WSANs, is exactly like running a marathon. It requires intense strategy, it requires careful pacing, and above all, it requires profound energy management. The difference between scraping a B and easily securing an A star in computer science often comes down to how well you understand this exact pacing strategy. Today, we're going to be looking at real past paper scenarios. We are going to introduce two hypothetical students, Alex and Sam. They both approach a 0417 paper, but in completely different ways. Alex tends to overload answers with raw facts but completely misses the analysis, while Sam rushes and totally ignores the command word requirements. We're going to look at their flawed answers side by side, covered in red pen marks, and then I'm going to show you exactly what the Cambridge examiners are actually looking for to help you secure every single mark. So, get comfortable, get focused, and get ready to pace yourself for the long exam haul.
Here is our explicit roadmap for today's explainer. We're going to show you the exact route we will take to build your maximum mark potential. First up, the exam marathon. Second, WSAN core principles. Third, the technical methodology. Fourth, mastering critical analysis. And finally, the top examiner warnings. Let's get straight into it.
Section 1, the exam marathon. This is where we introduce the primary challenge of the day: energy management and strategic pacing during really complex problem solving.
I want you to really visualize this for a second. Imagine you are sitting in that exam hall. You are an hour, maybe an hour and a half in. Your hand is cramping up, your brain is starting to get a little foggy, and suddenly, boom, you are hit with a massive 8-mark question on how a wireless sensor and actuator network operates within an autonomous vehicle. This right here, this is the wall. This is the exact moment where marathon runners either push through the pain or they completely collapse. The primary challenge here isn't just knowing the raw facts about sensors and microprocessors. It is entirely about energy management and strategic pacing. Because if you sprinted through all the easy questions at the beginning and burned through all your cognitive energy, you are going to misread the command words on this page. You're going to just dump information onto the paper rather than actually analyzing the scenario they gave you. To ace this marathon, you have to manage your cognitive load so that when you reach these monster questions, you have the mental clarity to execute perfectly. So I want to pose this direct question to you. Why do students find interpreting complex WSAN data so incredibly hard? It's a genuine knowledge gap that we see year after year in the examiner reports. The examiners know this topic is dense. You are dealing with continuous data from sensors, analog to digital converters, microprocessor logic, digital to analog converters, and mechanical actuators. And it's all happening in a continuous real-time feedback loop. When students see all this complex data, they panic, they rush. And rushing leads to the absolute cardinal sin of Cambridge exams, missing the crucial command word requirements. If the question says, evaluate the use of a WSAN in a smart home, and you just describe what a smart home is, you have immediately captured mark. No matter how beautifully you write or how much you write, you miss the command word. You sprinted in the entirely wrong direction. We absolutely need to decode those command words properly to even stand a chance at the top marks.
Let's look at a side-by-side comparison. On the left, we have Alex's answer. It is a complete and utter vague fact dump. It's overloaded with raw computer science facts about temperature sensors and motors, but there is zero actual analysis. Alex clearly panicked, didn't pace the exam, and just wrote down everything they could remember without once addressing the specific autonomous vehicle context. As a result, it's covered in red pen marks from the examiner. Now, look at the right side. This is Sam's rewritten answer. Sam uses the PEAL framework. That stands for point, evidence, explanation, link. It is incredibly specific, it is beautifully structured, and most importantly, it directly hits the command words. Sam paced the answer perfectly, earning maximum marks and a whole lot of green check marks. Structuring your answers like Sam is the ultimate secret to unlocking those top grades. We're going to break down exactly how you can replicate Sam's PEAL framework in your own exam papers, and trust me, it completely transforms your mark potential.
Section 2, WSAN core principles. We are transitioning to the theoretical warm-up required before we start running the technical methodology.
Okay, so what exactly are wireless sensor and actuator networks, or WSANs? Basically, they are integrated networks used in highly complex environments. We're talking smart homes, advanced guidance systems, and autonomous vehicles. But the key takeaway here is that they rely on systematic analysis and evidence-based reasoning. It is not just about the hardware. A WSAN is a complete, intelligent, closed-loop system. Imagine a self-driving car. You have sensors constantly gathering continuous, real-world analog data, like, say, the exact proximity of a pedestrian to the bumper of the car. That analog data is useless to a computer on its own, so it gets sent through an analog-to-digital converter, or ADC, directly to a microprocessor. The microprocessor then performs systematic analysis. It compares that digital input against preset parameters or complex algorithms. Then, it makes an evidence-based decision and sends a signal, often through a digital-to-analog converter, to an actuator. In this case, that actuator would trigger the braking mechanism to take immediate physical action. This continuous, closed-loop system is the fundamental conceptual framework you absolutely must understand. If you write in your exam, the sensor stops the car, you get 0 marks, period. The sensor does not stop the car. The sensor reads data, the microprocessor makes the decision, the actuator stops the car. Precision is absolutely everything in this marathon.
And here is a massive, incredibly valuable secret straight from the examiners themselves. Cross-topic connections equal maximum marks. The theoretical architecture of WSNs does not just exist in a vacuum. The principal examiner reports explicitly highlight that candidates who reference cross-topic connections achieve significantly higher marks. What does that actually mean for your grade? It means when you are discussing a WSN in a smart home scenario, you don't just talk about the sensors. You link it to network security. You ask, how is that wireless data being encrypted to stop malicious hackers from remotely unlocking the smart front door? You link it to databases. Where's all that historical temperature data being stored and how is it queried by the homeowner? You bring in concepts from syllabus 0478 or 2210 regarding data transmission, packet switching, and error checking methods like checksums or parity bits. When you show the examiner that you understand how WSNs seamlessly integrate with the rest of the Cambridge Computer Science syllabus, you are demonstrating true A-star level mastery. Before we continue, subscribe to our YouTube channel Ace the Exams, at acetheexams_IGCS, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 3, the technical methodology. We are moving into the core pacing strategy here, introducing the method mark strategy, where exactly how you arrive at the answer is critical.
I want you to think of this as your ultimate computer science success blueprint. This is a strict, 5-part procedural sequence that you need to memorize. Step 1. Identify key elements from the provided text or tables. Don't just skim, actively identify the variables. Step 2. Apply relevant principles. This is where you bring in your deep knowledge of ADCs, DACs, microprocessors, and feedback loops. Step 3. Execute the analysis with incredibly clear working. Show the examiner exactly how your brain is processing the problem. Step 4. Verify your results. Does the outcome actually make logical sense in the context of the question? And Step 5. Present your answer in the correct format. Following this exact sequence systematizes your WSAN processing. It means that even if you start to panic or your brain fogs up under pressure, you have a rigid mechanical process to fall back on. Applying a systematic blueprint like this 5-step process is exactly what takes a student from a C or a B straight into that A-star territory. But let's look at what happens when you completely ignore Step 5 of this process. Let's do a quick visual challenge here. Look at the left side. This is a classic example of poor presentation. It's a messy, generic, unformatted block of text. It completely fails because it lacks professional skills, practical application, and proper formatting. Now compare that to the right side, which follows strict conventions. It uses proper headings, highly specific correct terminology, for example, using the phrase embedded microprocessor instead of just saying a computer. And it features clear, logical annotation. The examiners emphasize that professional skills marks are quite literally won or lost in the practical application of these formatting conventions. When you are rushing and sprinting through the paper like Sam used to do in early mocks, you write generic, messy text. When you pace yourself like a marathon runner, you use strict conventions. And honestly, those extra 2 or 3 presentation marks can literally bump you up an entire letter grade boundary. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4. Mastering Critical Analysis. We are shifting into the final sprint of the assessment objectives now, focusing heavily on the higher-order evaluative thinking required for top scores.
Okay, I really want you to pay attention to this breakdown because this shows exactly how examiners classify your answers and award marks. We have 3 tiers of assessment levels: descriptive, analytical, and evaluative. At the base level descriptive tier, your action required is just to extract texts and tables and maybe identify some basic limitations of the evidence. Honestly, this only gets you passing marks. It's the bare minimum. To level up to the analytical tier, you must start to compare approaches. For instance, you might be asked to compare the use of infrared sensors versus ultrasonic sensors in an autonomous vehicle's WSAN. What are the specific assumptions made in each approach? How do environmental factors like rain or fog affect one sensor over the other? Finally, we reach the top tier, the Holy Grail, evaluative. Here, you must justify recommendations and assess the effect on conclusions. Let's say a smart home WSAN fails to detect a fire early enough because the smoke sensor was placed too far from the kitchen. An evaluative A-star answer would question the assumptions made during the installation, justify exactly why a different network topology would be safer, and use solid technical evidence to back up that recommendation. Top-scoring candidates demonstrate this evaluative thinking by constantly questioning assumptions. They don't just accept the data presented in the paper, they critically interrogate it.
We have initiated the final segment, Section 5, Top Examiner Warnings. We are addressing the most dangerous pitfalls that trip up runners right before they cross the finish line.
So what goes wrong? I've gone through the principal examiner reports, and I've pulled out the top 3 explicit warnings. These are the exact mistakes costing students their A-stars. Number 1. Answers are simply too vague. As we discussed earlier, saying a sensor sends data to a computer is way too vague. Examiners want specific technical details. They want to see an analog temperature sensor transmits continuous data through an ADC to the embedded microprocessor. Number 2. Forgetting to check format and presentation conventions. We just covered this in the blueprint. Do not throw away easy professional marks because your answer is just a massive, messy block of text. Use your headings, use bullet points if appropriate, and structure it cleanly. And number 3, and listen to me closely because this is perhaps the single biggest trap. Answers are not specific to the given context. I cannot stress this enough. Context is king. If the exam question asks you about a WSAN in an agricultural greenhouse monitoring soil moisture, and you write a perfectly accurate, beautifully structured essay about a WSAN in an autonomous vehicle, you will score 0 marks. 0. You must tailor every single point, every piece of evidence, and every explanation of your Peel framework to the highly specific scenario provided in that exam paper. To really hammer this home and provide a visual breakdown, let's look at exactly where your focus and energy need to go. Look at this distribution. A massive 40% of your score relies entirely on context specificity. You can have all the perfect terminology in the world, which as you can see, makes up a 30% slice, but if that terminology is not applied to the specific problem in front of you, it is completely useless. Then, cross-topic links take up about 20% of your mark potential. Bringing in that network security, those databases, that data transmission knowledge is incredibly highly rewarded. And finally, presentation is that crucial 10% that can easily bump you over a grade boundary. Managing your energy throughout the entire paper so that you can consciously hit all 4 of these factors in that final, grueling hour of your exam, that is the ultimate pacing strategy.
And this brings us to the ultimate golden rule of today's explainer. This is a direct, word-for-word quote from the Principal Examiner report. Even if your final answer is wrong, method marks can save you. Show you're working. This is the ultimate safety net for the marathon runner. When you are evaluating a massively complex WSAN dataset, write down your logical steps. Document your systematic analysis right there on the paper. If you make a tiny calculation error or a small logical misstep at the very end, but the examiner can clearly see your correct procedural framework and your Peel structure, they will award you method marks. You have to trust the process. Show every single step of your working, because a blank space guarantees 0 marks, but a flawed final answer with a brilliant, clear methodology can still score surprisingly high.
So I want to leave you with this provocative thought to really reflect on your own study strategy right now. Are you currently running a sprint, or are you pacing yourself for the A-star marathon? Cramming raw facts the night before the exam is a sprint. It leads to immediate burnout and incredibly vague answers. But mastering the Peel framework, truly understanding the deep theoretical architecture of WASNs, and meticulously practicing your formatting and your cross-topic links, that is how you train for the marathon. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainers. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here.